Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 8, 2025, which was about 4 days ago. The main idea is a unified system that lets you edit and generate images using both text and reference images, and it handles abstract attributes like texture or style while beating popular open source baselines and nearing some commercial systems. The paper is titled DreamOmni2, Multimodal Instruction-Based Editing and Generation. And, as we'll see later, the results are really impressive. Beyond the headline, the work introduces a 3-step synthetic data pipeline, multi-image index and position encoding to prevent pixel confusion, joint training with a vision language model for complex instructions, and a new real image benchmark. Also, the authors shared the official GitHub repo. You'll find the full DreamOmni2 code for multimodal editing and generation, ready to run inference scripts, lightweight web demos, requirements and model weight setup, example inputs, and utilities. Clear, quick start commands walk you through editing versus generation workflows with a benchmark release and practical configs. Alright, Figure 1 illustrates what the system enables. Unified editing and generation driven by multimodal instructions, which means the prompts can include both text and reference images. The gallery shows diverse cases where objects, styles, materials, and poses transfer across images. These examples matter because they mix concrete entities with abstract attributes, so the model must track which image provides which clue. Together, the panels preview the full task space the method targets. So Figure 2 outlines the 3-stage data engine that powers the method. The top panel shows feature mixing inside a diffusion transformer, which blends source and target attention streams so paired images share objects or abstract traits. The middle panel builds editing triplets by using an extraction model to craft references and an editing model to create a source image. The bottom panel assembles generation data by extracting multiple references from those sources, yielding rich multi-image supervision. So Table 1 summarizes how the benchmark landscape differs. The table contrasts DreamBooth, OmniContext, and DreamOmni2 across task type, number of references, and what the editing target covers. DreamOmni2 is the only one that supports generation and editing with multiple references and handles both concrete objects and abstract attributions, which matters because practical requests often mix identity with style or pose. In short, the benchmark scope is broader and more realistic. So, Table 2 reports head-to-head editing success for multimodal instruction-based editing, split into concrete objects and abstract attributions, with scores from 2 vision language models and human judges. The bottom row shows DreamOmni2 leading in human evaluations across both groups, reaching about 0.68 on abstract attribution. It also posts strong results on concrete objects with humans around 0.61, while staying competitive with commercial systems. The remaining gaps reflect issues like color shifts and attribute drift that automated judges may not reliably detect. Wrapping up, 2 takeaways stand out. The system unifies editing and generation with multi-reference control, reaching strong human-judged quality, and the simple index encoding with position shift plus vision language model joint training clearly boosts reliability on abstract attributes. The broader implication is more faithful, user-steered visual creation at scale. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.